Hello and welcome. This is going to be our homework help video for the Piecewise homework. Let's go ahead and get started with problem number 1. Sketch the graph of each function. So kind of similar to graphing linear equations, you start at the end and work your way backwards. So when you graph a linear equation, you start at the y-intercept and then attach the slope. With Piecewise, we start at these inequalities and specifically at the number at the very end. I'll just say start, and then you work your way backwards. So I see 0 is the number, that we call that 0 our boundary value, and we want to add a vertical dotted line at 0. So it's going to go right along that x-axis, and that's where we're going to switch from being the top equation to the bottom equation. Now for that top equation, we want to write it with a y equals, so y equals -3, and then we want to dot that all the way across the graph. So we want to put in dots all the way across the graph at y equals -3. Remember, y equals equations create horizontal lines. All right, and then we just only want to fill in, for the top equation, you fill it into strip 1. So we're just going to connect these dots over here all the way up to that boundary and then stop. These dots over here can actually be erased. All right, this side over here, this strip continues on forever, so we get an arrow, but it stops right here. All right, for the next one, this is a y equals -1. So I know that's going to just resume at this dotted line, so I don't have to dot it all the way across the graph if I don't want to. I can just dot it over here where I know it's going to be. And there's that line. So as we go left to right along this function, we're at -3 until we hit 0. Then we hop up to 1 or -1, and we continue on at -1. But what do you do exactly at 0? We're going to show that with dots. Because this top one has the or equal to in its inequality, it gets a closed dot. And then the other one doesn't have an or equal to, so it gets an open dot. So an open dot right here at the start of this line, and then this ray continues on forever. All right, let's try number 2. So where's my boundary value? Well, it's right at 3, so I want a vertical dotted line that hits the x-axis at 3. There we go, that's the boundary. We're going to switch from being on one line to the other. Now I want to graph that top equation. I'm going to rewrite that as y equals 3. So it's going to be a horizontal dotted line at 3. But I'm only going to keep the dots that are on the left of the boundary. All right, it runs into the boundary. This side gets an arrow. Now I go to the next one. This is, we can write it with a y equals x minus 2. So start at -2, add that slope of 1. I'm not even go to the left because I know I only want this section here in strip 2. And then right at the boundary, which one gets the closed dot? It's the top one. The first one gets the closed dot. The next one gets the open dot. All right, I can even get rid of these dots. They're not part of the function. Okay, let's see. Number 3, that's pretty similar. 4 is pretty similar. Let's just jump down to 6. So I'll do 3, you'll do 3. Where's my boundary value? Well, it's at -4. So I want a vertical dotted line that goes through -4. So there's my boundary, cutting my graph into 2 strips. Strip 1 is this narrow strip over here. Strip 2 is this whole region over here. Let's write down that first equation with the y equals. So y equals x plus 3. That's a linear line with a y-intercept of 3 and a slope of 1. The slope of 1 is going this way, but I only want the section that ends up in strip 1, so I only need these dots right over here. Arrow going off the graph. Go ahead and erase these ones, they're not needed. And then the bottom equation. Write that with a y equals, it's y equals -2x minus 2. Put a pointer y-intercept of -2, then go down 2, right 1, down 2, right 1, down 2, right 1, or reverse it by going up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1, until we run into the boundary. Connect up these dots. Better job. connecting them, arrow on that side, and then which side gets the closed dot? It's the red line, because it has the or equal to as part of its inequality. So right at -4, we're still in this line. The second we move past -4, even -3.99, we jump onto this line over here. Okay, let's see. Is there anything else that's going to be tricky? Nope, those are pretty darn similar. The one, this one here. Here's another one. This number 5 is really similar to number 1. Peek at the answer key, and have a good rest of your day.